In our last class, we talked about graphing linear equations using a table of values. And we used our equation in standard form. Well, I want to go back to standard form for just a few more minutes and talk about how linear equations in x and y can be written in this ax plus by equals c form. But when a is equal to 0, the equation reduces to by is equal to c, and the graph of this line is a horizontal line. When b is equal to 0, the equation then reduces to ax is equal to c, and the graph of that line is a vertical line. So we're going to investigate this a little bit more today. We're going to look at those graphs. Let's take a look at an example of y is equal to 2. And as mentioned above, the graph of this is a horizontal line. So as we're looking at this, we're trying to figure out how that is true. And let's talk about some of the points. It says that y is equal to 2, which means it's a constant. And it's always going to be 2. So let's look at some of the ordered pairs that are graphed here. If I look at this point right here, this is now -1, 2, 3, 4. That point is -4 and up 2. Let's look at this point over here. That's -1 and up 2. The point that lies right here, 1, 2, 3, is 3, 2. So maybe you're starting to notice that no matter what my value of x is, y will always be 2 because it is constant. So we see that that forms the horizontal line. Now let's look at when x is a constant. And I can even think of this as a little bit of table here. And if I say that x is always -3. Well, what if x were -3 and I looked at this point here? And that goes up 1, 2, 3, 4, 5. And then I have -3 again. And maybe this point is 2. And I have -3. And maybe this point here is -2. So you see that, again, I'm getting this constant. No matter what the y value is, x is always 3. I can do the same with this one too, thinking of that table of values. Whatever value I pick for x, y was 2. Forming this relationship here, and this is my horizontal line. And the slope of a horizontal line is 0. No slope at all there. The vertical line, which we'll investigate a little more later on, has a slope that is undefined. So we'll be talking about this a little bit more, but that was just a little bit of an example where I could highlight something that's coming up in the near future. Now let's talk about one more time about graphing linear equations. We did it with the table of value, but there's got to be an easier way, and there's actually two. We realize that when we're graphing a line, there are an infinite number of points, but we only need 2 points to graph the line. So we're going to rely on 2 key points, the point that falls on the x-axis, which is your x-intercept, and a point that falls on your y-axis, your y-intercept. In my first couple of examples, and again, we did do a brief mini lesson on this previously, if I give you the x-intercept, that's a point that falls on the x-axis. If I give you my y-intercept, 1, 2, 3, 4, 5, it's a point on the y-axis. The opposite coordinate was 0. In this first one, it was -2, 0, didn't go up or down. And then this other one doesn't go left or right, but just counts up 5. What happens now? I connect those points. All I needed was 2 points to graph. We're going to recall, and I'll keep highlighting these things so we get very familiar with this. This line rises from left to right, and has a positive slope. I want to do another example where I give you the intercepts and we don't have to find anything. So far, this is pretty easy and a lot less work than the last type. Let's take a look at another where I give you the intercepts. X is equal to 4. 1, 2, 3, 4. There's my first point. It's a point on the x-axis. It's my x-intercept. My y-intercept is -1, 2, 3. A point on the y-axis. The coordinates here are 4, 0. So when x is 4, y was 0, and then this one I have 0, -3. Connect my points, and there's my line. Arrows at both ends because it's a line, not a line segment. Let's just do, and this one again rises from left to right. It has a positive slope. So right away we're seeing there's not a lot of work to this so far. We always start with the easy ones where we don't have a lot of work. Last one of this type, -2, is my x-intercept. And -4, 1, 2, 3, 4. My second point on my y-axis, and I did that wrong. Let me redo that, please. Okay, let's try that again. My x-intercept is -2, 1, 2, and my y-intercept 1, 2, 3, 4. Sorry about that. And there's my line. And that one has a negative slope. It's going downhill. But now on to the part where we have to do a little bit of work. What kind of work will we have to do? We have to find our intercepts. So in an equation in standard form, 2x plus 3y equals 6. I have to find the intercepts. I wasn't given the values. So in order to do this, we're going to set one of the variables to 0 and solve for the other. We're going to go to do between the two. So let's go and start with finding, and it doesn't matter which one we start with. Let's find our x-intercept. We'll set y equal to 0. So I'm going to have 2x. I'm going to replace y with 0. And shortly you'll see you really don't have to even do this because we know this term is going to cancel out. And I have 2x is equal to 6. So x is equal to 3. So when y was 0, x was 3. Let's graph that. 1, 2, 3. There's my point. Now let's do the reverse. To find my y-intercept, let's set x to 0. So that's 2 times 0. And again, that term's going to cancel out, so I technically don't even have to write that. But I'm doing it for the introductory couple problems here, just so that you see. And we'll divide by 3. And y is equal to 2. So when x was equal to 0, y was equal to 2. 0, 1, 2. We have 2 points. And we connect those points. We're never done until we connect. And arrows at both ends. Let's just try at least one more. To find the intercepts, again, I give you the standard form. We're going to do them one at a time. I'll start by finding my x-intercept. And when I do that, I'm going to set y equal to 0. So again, we're thinking about how to do this. So if -2x, again, last time I'm going to do this, I'll replace y with 0. And I'll see I get -2x is equal to -8. Lastly, divide, and x is equal to 4. So now we'll go ahead and graph that. And again, a rough sketch is all you need. 4, 0 is right on that x-axis. It's the x-intercept. To find the y-intercept, let's set x equal to 0. So I'll have negative 2 times 0. And again, you're going to see that we can go right to the second step. And in the second step, I'll have 4y is equal to negative 8. And y is equal to negative 2. Let's find that on our graph. Negative 2. And then we'll draw the line and we'll see we have a positive slope. So we'll do more examples in class, but these are a couple to get you started. And again, something that we've tried before, and hopefully you feel comfortable with this material.